A block of mass m is moving at a constant speed along a curved path which forms a part of circle with radius r. The coefficient of friction between the block and the ground is mu. Part A. Determine the maximum speed at which the block can pass through this curved path on Earth without slipping. So for part A, the most important part is to determine which force on the block is the centripetal force. So let's draw a free body diagram. Of course, there's a gravitational force that pulls it downward, right? Oh, by the way, this is like a horizontal surface, so it's like you driving on the ground. And this is the normal force, and there is a frictional force. I can just tell you the conclusion that the FF is the centripetal force, but you may forgot. So let me explain. Imagine you're driving on the frictionless surface. Mu is very, very close to zero. Like when you're driving on a frozen lake, you're driving a car, right? Driving it straight forward, and suddenly you see a McDonald over here, and you want to turn. So you turn your steering wheel to that direction, right? And realize that your car cannot turn at all. You cannot control your car. Your car just go straight forward, like there's nothing happen, even though you turn the steering wheel, even you take off the steering wheel. So the car is still moving like that, right? So in this situation, there will not be a circular motion, right? Because your car is just moving forward, and there are only two forces that act on it, which are the normal force and the gravitational force. So in this situation, we can clearly see that Fn and Fg will not be the centripetal force, because if one of these are centripetal force, the car will be moving in a circular path. But obviously, when you're driving on an ice surface, in this situation, you're not moving in a circular path. So these two forces cannot be the centripetal force. Now, situation number two. Now you're driving on a normal road. Mu is close to point A. Oh, and then you see a McDonald over here, and you're so hungry and you want to turn, so you turn your steering wheel to that direction again, right? And you, oh my, I can actually turn my car toward that way. In this part, when you're turning, you can see this is a part of circle, just like this question's graph. So in this part, you actually do a circular motion. So in this situation, there's three forces that act on you. Compared to the previous situation, there's one more force, which is a friction force. In the previous situation, we conclude that neither Fn nor Fg will be your centripetal force, so Ff will be your centripetal force. So Ff is your centripetal force. I think that's quite easy to understand because that's how I understand it. So I wish you can understand it. If you have questions, just ask me in the comment section. Alright, so let's do a free body diagram again. So this is a centripetal force, right? What is the formula for the friction force, Ff? It is equal to Fn, the normal force, times mu, right? In this situation, since the vehicle is on the ground and it's not flying above the ground or diving under the ground, so Fn and Fg are equal. So we can just replace Fn with Fg here. Ff is equal to Fg times mu, and it is equal to mg times mu. And since this is a centripetal force, we can write this is equal to Fc. And since there's only one force that's pointing toward the circle, so we can write it is actually the only force to act toward the circle, so we can write it's equal to m. So it's actually equal to the net force towards the circle, which is equal to mv squared over r. This is the centripetal acceleration. If you don't understand it, just check your formula sheet. So let's pick two parts of this long equation that we need. Let's write them out. Mg mu is equal to mv squared over r. M can cancel out, obviously. What is it asking you? Determine the maximum speed at which the block can pass through this curved path on the Earth without slipping. So it's asking for v. After cancel m, we can get g mu is equal to v squared over r. So we can get v is equal to the square root of r times mu times g. I will call it a rug. Yeah, a rug. Because it looks like a rug and it sounds like a rug. And it's like a it's like a funny conclusion that you can like remember when you're doing like in this scenario. Well, if you don't want to like remember it, just ignore it because I think that's quite funny. All right, part B. Now consider the same situation on Jupiter, where the gravitational acceleration is equal to like 2.53 g. A block of mass 2m moves through a similar curved path, but the radius of the circular path is 3r. Determine the ratio of the maximum speed, in this case, to the maximum speed found in part A. So, you don't need to solve that thing again, because we can literally just use the conclusion or the velocity expression we get from the part A to help us find the answer. However, this time we're on Jupiter, not on Earth, so we're supposed to plug in the new value. So over here, v, Jupiter, is equal to square root of rho, of course, but now with some like coefficient. What is a new r? New r is equal to 3r. 3 times is equal to 3 times of the original r, right? So we can write 3 times mu. In the question it says similar curved paths, right? So mu stays the same. What is g? G is equal to approximate 2.53 of g, right? So we can write times 2.53 of g. Now let me introduce you the once method. Switch color. Where is it? Once method. So the essence of the once method is basically like switching the part you already know to 1. For example, over here, you can assume that all r and mu and g are all 1s. So we can write it is 1, 1, 1. And then let's see over here. Let's see in Vj, the expression of Vj. Over here, we already know the r is 1, right? 1. Mu is 1, right? 1. G is 1, right? 1. So it is equal to square root of 7.59 times r times mu times g. So it's basically like 7.59 times 1, 1, 1. This is 1, 1, 1. So the ratio will be Vj over V is equal to just because these are 1 times 1 times 1, right? And these are 1 times 1 times 1. These are also 1 times 1 times 1. So this 1 times 1 times 1 can be cancelled out. And the final ratio will be the square root of 7.59 over 1, which will be 2.75. And this will be your answer.